Today we're talking about comparing y-intercepts. A y-intercept is just the exact same thing as the starting point. It's where the x value is equal to 0. So on a graph, it'll be where the graph crosses the y-axis. On a table, it'll be where x equals 0. On an equation, it'll be the number by itself, and in a story or a word problem, it'll be what happens once or what you start with. So first examples here, we're going to find the y-intercept from some equations, which again is the number by itself. It's the number without a variable. So for this first one, that would be -10. We write that as a point, 0, -10. Next one, that would be -3. So 0, -3. -3 does not have a vertex, or a variable next to it. Okay, on the next guy over here for C, first thing we need to do is combine like terms. So I would get 5x minus 10 is equal to y. The number by itself is -10. So 0, -10. Make sure you take the sign in front. And the last one here, this is a quadratic, but we can still look for the number by itself, which would be positive 63. So my y-intercept will be 0, 63. Looking at these equations, we want to see which one has the greatest y-intercept. Well, the biggest number here is 63. So y is equal to 3x plus 63 plus 2x squared has the greatest y-intercept, or the starting point. So this one. Moving on to graphs. What is the y-intercept for the following graphs? Well, remember, on a graph, it is where the line or the graph, where it crosses the y-axis. And remember, the y-axis is the vertical axis. Okay, so for the first one, I see that it crosses right here, just like the starting point, exact same thing. This is another name for the y-intercept. It's called the y-intercept because it's like intercept, like in football, means crossing, to cross over and like take the ball. So it's crossing the y-axis there. Y-intercept, cross the y. So that is the point 0, -5. Remember, we're also looking for x equals 0, and on the y-axis, x is always equal to 0. Next one. This is what we call an x-intercept. We're not looking for the x-intercept, but I'll point that out. That is called the x-intercept, but that's not what we're looking for right now. What we care about is the y-intercept. The x-intercept is just where the line crosses the graph crosses the x-axis. So if I asked you for the x-intercept, you would say 3, 0. But because I'm asking for the y-intercept, you're going to say 0, 6. But this is the one we care about. And you see that point right there at 0, 6. Last graph here is a line. That line crosses the y-axis at 0, 2. So this is my y-intercept. And that is the point 0, 2. Same thing as we did for the starting point. So which graph has the greatest y-intercept? We got -5, 6, and 2. The greatest is going to be the middle graph. At 0, 6 is the greatest. And which graph has the smallest? We have -5, 2, and 6. -5 is the smallest, so the left graph, which is at 0, -5, is the smallest. Don't overthink it. -5 is the smallest number, 6 is the biggest number. Now we'll talk about tables. Remember the y-intercept is where x is equal to 0. So let's see, on this first table, x is equal to 0 at 0. So that starting point is going to be 0, 0. I'm going to go to the table to the right. X equals 0 at 5. So we write that as a point, 0, 5. Because if you were to graph this, that would also be where it crosses the y-axis. In the last one, x equals 0 at 15. So that's the point 0, 15. So which table has the greatest? I'm going to letter these. This is table A, B, and C for my purposes. Table C at 0, 15 has the greatest because 15 is the biggest number. Which one is the smallest? Well, that would be 0, 0, so table C. No, I'm sorry, table A at 0, 0 has the smallest. Perhaps the most important part about what we're learning today is that you can compare from different forms. So we're going to look at a graph, a table, and an equation and compare all three. All right, for the graph, I see that its y-intercept, its starting point, is right there at 0, -3. For the table, x equals 0 at -5, so I'll write that as a point. And for the equation, it will be at -7, so 0, -7, because that's the number by itself, no variable next to it, because y is equal to everything already. So which one has the greatest? Well, remember these are negative numbers, so -7 is actually the smallest number here. -3, if you think about, like, if you're in debt $3, that's a lot better than being in debt $5 or $7. So the graph has the greatest y-intercept at 0, -3. And that's because it's the greatest number.